All right, in this question, we're asked to use a little bit of our estimation skills. So if you haven't done so yet, see if you can kind of eyeball this and estimate a little bit. But start with this first question. How many students made a C or better? So what I want to do is I want to just come in here and do a little bit of estimation. So it looks like there are maybe 6 students who earned an A, maybe 14 who earned a B. We're going to go with 24 who earned a C. D is a little bit above 15, so we'll say 16. And F looks like we got about 2 students there. So having those numbers before I look at the questions are going to help me do a little bit better job estimating. So approximately how many students made a C or better? So what I'm really asked is what's 24 plus 14 plus 6? So let's see, that's 44. How many more students received a C than an A or B? Okay, so we're comparing 24 versus the 6 plus 14, which is 20. And specifically, we're said how many more students. So if there were 24 that got a C, then the A and B, that would put me at around 4 students. So the difference would be around 4. Again, keep in mind there's a little bit of flexibility with some of these answers. How many students were in Mr. Mulligan's class last year? Okay, so we're asked, hey, just add these numbers up. All right, so, well, let's see, 16 and 14 is 30, plus the 24, so 54, plus the 6 is 60, so 62. So right around 62 would be my estimate for this. Okay, so in this question, we're asked to identify positive, negative, or no correlation whatsoever. So one thing that would help us is, I'm going to add a little bit more space here, because I would like to think about, as the first one goes up, what would I expect to see in the second quantity? So as airspeed goes up, so increases, what do I expect about the time it takes to get there? I would expect that to go down, because if you're traveling faster, you'd actually get there faster. So that time should decrease as that thing increases. So that's actually a definition of negative correlation. So I'm going to write negative there. Okay, so let's see, accidents. So as that one increases, what would I expect about insurance? So as your accidents increase, your insurance should increase. Okay, so that would be an example of a positive correlation. Shoe size. So shoe size, as that one increases. Education. Education, as I spell that all sorts of weird ways. Okay, so as the shoe gets bigger, does that mean the other person is smarter or dumber, or what does that even mean? I hope we all reached the idea that I have no idea. That's not a fair statement. So that would be an example of no correlation. And then this last one, daylight. So as that increases, what would be amount of electricity for lighting? Could I put the little clarifier there? So if we have more daylight, do I have to go turn on my lights, or do I have to turn my lights on less or more? And that would make sense that the amount of electricity for lighting should go down if there's more light outside, generally speaking. Now, other uses might go up, but we're specifically citing this in terms of home lighting. And so if one quantity increases, the other one decreases, that would be an example of negative correlation. Number 17, we're given a bag of marbles, and we're asked to look at drawing the probability of a red one from a bag. I'm gonna actually change this question up. I'm gonna answer this question, but I'm gonna change it up to kind of illustrate a couple of different topics we've seen. So let's just do drawing one red. That's pretty straightforward. But let's also do drawing 2 red with replacement and drawing 2 red without replacement. And again, the reason why I'm doing this is even though this question is about that one case of 1 red, on the final it could be the other 2 cases. So the whole point is that you go back and review these things. So I'm going to pull up the spreadsheet for statistics on this, and then we'll use that to kind of review these ideas. Okay, so pulled it up, but I didn't show you. So I've got it pulled up here. And it's always good to kind of review what each part of the spreadsheet does, so you're not shocked a little bit when those questions come up. All right, so drawing 1 red. Well, how many reds are there? There are 4, and I don't really care which one of the 4 I get, but they're 4 out of, and we actually didn't calculate the total, so I want to do that at some point, figure out what 4, 5, and 3 happen to be. So 4 out of 12. And let me jump into the spreadsheet here. So 4 out of 12. So that's decimal form is 33.33. Fraction form is 1/3 percent, which doesn't say on the spreadsheet, but that's 33%. So 1/3 would be great for that answer. But what if I draw 2 out with replacement? So the idea is I reach in, I grab one, and then I draw a second one. Well, first time I reach in is 4 out of 12. Second time I reach in, if I'm putting it back in the bag, that's 4 out of 12 again. But when I do it without replacement, that's where it's going to change on me, which is why I want to illustrate the difference here. So the first time I reach in, it's 4 out of 12. But if I keep one out, then instead of having 4 the second time, there's actually 3. And instead of having 12, there's actually 11 total. And so we'll go back in Excel here and do both of those so we can get a simplified fraction. Okay, so equals 4 divided by 12 times 4 divided by 12. So that's 1/9. And the other case is 4 divided by 12 times 3 divided by 11. And that's 1/11 there. So notice you get a different answer. So just be aware of all these different ways that these types of questions could come up. All right, the tricky part of number 18 is you have to remember what the probability distribution looks like for a 6-sided fair dice. So there's a chart that I showed you about all the dice combinations and how likely they are to show up. So see if you can, from memory, generate that chart. That's going to be the only reason why you don't get this one right. So let me kind of, now you've had a chance to practice it. Here's what it should have looked like. Let me see if I can get this with the question there. Oops, same time. All right. All right, what's the probability of getting at least 1/6 when rolling a 6 fair-sided dice? Okay, so we can kind of, one way we can do this is we can look at the chart and count up how many times a 6 shows up. So there are 6 times here and 6 times here, but this guy shows up twice. So it's really these 6 and these 5. So 11 out of 36 would be one way we could get this answer. Another way we could do this is we could look at our formula chart and we could think of this phrase at least, or at least 1, and that should show up. So let me kind of pull up the formula chart here. So in our spreadsheet, we're asked for the at least formula. We're asked to identify the probability of success. So when I toss one die, I would consider it a success if a 6 shows up. So that's going to happen 1 out of 6 times. And there are 2 dice that I am tossing. So that's the other way that we can generate this. So either be really good at your at least formula or be really good at your sample space. Either approach is completely fine.